My name is Troy Schultz. I'm the president of Technical Design Services and Virtual GIS software. I have a background in construction, environmental work, engineering, CAD design, civil design, survey work. I worked as a contractor doing heavy equipment operation, labor, foreman. I've kind of covered the whole gambit of construction work out there. The next slide there, Nick. At Technical Design Services, we do survey work, engineering design, GIS work, and CAD design primarily, as well as environmental, I guess. Virtual GIS software came out of kind of a creation which at a point in time in our line of work in our industry, we needed this. We needed a GIS software that was a solution to presenting utilities, presenting information for our clients, and we ended up developing our own solution, as well as we developed a 3D pipes solution and an open source 2D solution, which led to then our augmented reality software. Go ahead, Nick. We have a little explainer video to kind of show what we've developed here over the last few years, what we've been working on, I guess. I'll have Nick play that.
Yeah. You want to mute yours and then while it plays? Is it going? Oop.
Tracking and understanding underground assets can be complicated, but it's essential to your operations. You have 2D maps, plan sets, and alignment sheets, but these can be very difficult and complicated to understand. Also, vertical information is missing, which makes it difficult to tell where each utility is under the ground. Other times, you may be out in the field only to realize that not all utilities have been located. Wouldn't it be great if there was a better way? Introducing Virtual GIS. Virtual GIS takes your existing project data and turns it into an intuitive 3D visualization. In 3D, depth, bends, and crossing utilities are clearly visible. You don't need much to get started. Latitude, longitude, and elevation are sufficient. You can import from dozens of formats, including CSVs, shapefiles, geodatabases, and GeoJSON. Virtual GIS works on any modern PC, tablet, or smartphone, so you can access your project from your office or directly from the field. You can also use our augmented reality display to see your underground assets overlaid to the camera feed of your mobile device. It's like having X-ray vision in the field. You can use this display to retrieve information in real time and easily take measurements. Virtual GIS enables you to better understand your project. It's a tool you can use to communicate more effectively with every stakeholder so that everyone can work more efficiently. Contact us today at virtualgis.io to see how 3D visualization can improve your project and give you a better understanding of your assets.
Stop that. So that's okay.
Go ahead.
So that's kind of a brief overview of what we've been working on, what we've developed here over the past few years. Yeah, so technology is evolving quickly, and it really started out with more of a 3D viewer technology that we were working on, and Piero, my developer, programmer, once we got our 3D software kind of developed, then the next thing was augmented reality, and we moved forward into augmented reality. So that's kind of where we're at. I'll let Nick go more into detail on this stuff. But from my perspective, the reason I'm involved with this is because I grew up in a family-owned business, a construction company, and lived and witnessed the dangers in the real life of what goes on when utilities aren't located properly, or they're overlooked. Utility locates are overlooked. So this video here that Nick's going to play is something that happened personally to me. It's just an example, but it's not what happened to me, but it's something that I did actually experience. I cut when I was young, I guess I was about 25 years old, working as a heavy equipment operator. I cut a line just like that, and it really scared the heck out of me. Could have easily died, or someone around me could have gotten killed. So that's what my motives were behind, pushing harder to want to develop the software that could help prevent these types of things. Nick, I think I'll let you take it here.
Sounds good.
So I'm going to turn it over to Nick, who's going to give you more details.
You're muted now. Okay. Sorry about that. Like I said, we're in the same room, so we're going to get some echo when we transfer back and forth. So we didn't practice that ahead of time. So, all right. So, can you hear me? Okay. You good? Okay. Thank you. Yeah. So I'm just gonna, I guess, start from the basics. So, so what is augmented reality? In short, it's when you overlay digital content information onto the physical world in some way. And I'm sure, most of you are familiar with it to some degree or another. Like many shopping sites like Amazon, you can look at a couch in your living room or whatever. Teacup is the example there. And I'm sure you've seen people with the augmented reality glasses like Google Glass or the HoloLens. Or Pokemon Go is a very popular example of augmented reality on mobile devices, and it's obviously featured a lot in science fiction movies and whatnot. And so, but for perspective that we're looking at today, we're going to talk about kind of the marriage of GIS and augmented reality, which our ProVision AR app would be considered to be in that realm. So what does that mean? I mean, it's pretty simple. Overlays the geolocated information that you have and displays it based on your physical location in the world. So, so that example I have there is actually at my house. It's a kind of a crude example of an electric line running from my yard light over to my house. And it's just me playing around one day. So that's that line that's on there, if I was to walk around, you'd see it stay in the same spot. But yeah, so the way technology works is it tracks your physical location using GPS, of course, and the sensors on your device. So there's obviously the camera is a primary sensor on well, I'll show you this in a little bit, but so it uses the camera and other sensors on the device to track your immediate location, whereas the GPS is locating in the world. And environmental scanning technology in mobile devices detects the horizontal planes. So if you've ever used any of those shopping apps that you can place an object in your room or similar apps, that usually there's a calibration, procedure that starts out the experience. And what that's often doing is just detecting where ground planes are using the device's sensors. In the case of underground utilities, the horizontal planes are the ground. So that's how it knows where to either reference things above or below ground, depending on the scenario. And you can see on the calibration screen on our app, there's the 3 check marks, the planes, talked about that. The orientation, what that's doing is actually, when you're walking along in a straight line, it's doing 2 things. It's detecting the planes, and it's also taking your GPS coordinates in multiple locations to correctly orient you to true north, essentially. And then our app, we have the accuracy checkbox is just saying that your GPS accuracy is within whatever parameter we set that to be. So, and obviously, to help all that out, you need some sort of map to make sure you're, I guess, so the app knows where you are and you know where you are, and you can see an overhead view of what you're looking at for reference. And those, are often either like an Esri-based map, or in our case, we use Mapbox and that's just a straight up imagery on that example. And that's also my house there, and you can see my different color coded utilities coming in. I actually had a new cable line installed, so that's why I was lucky to have all those marked in my yard for me. And then you can see those dots, that green, and there's a blue dot you can barely see underneath it. And what those are is, well, the green dot's your GPS location, and the blue dot is actually where the AR thinks you are, and you can see they're diverging a little bit there. So that means my I guess the accuracy of what I'm seeing might start to waver as those get further and further apart for a variety of reasons. Either you're turning around too fast or moving too fast, or your GPS signal's getting bad. So it's just another way to verify what you're looking at is, I guess, as good as it can be. Next slide. So this slide is just a video we like to show of a I guess a pilot project of a kind of a prototype version of our app at a compressor station for a client. And actually, I'll turn it over to Troy to talk a little bit more about that in detail, since I wasn't actually there. But we really like the video because it really showcases the way the app works with showing things below ground, above ground, and how it actually how you can interact with it as you walk around. But I'll let Troy. Whoops, sorry, dang it, start it over. Let Troy speak to it a little bit more here, and I'll get that fixed. So I'm going to mute myself, Troy.
Okay, yeah, as Nick said, this is it's a screen recording where we had one of the engineers on site on this was a compressor station that was half designed already. It was 50%, or I'm sorry, half built. 50% of it was already built. They'd given us the design for the second half, phase 2. And so we took that design. It was a Navisworks project, and we were able to put the design into convert it to an AR model, and then we're able to push that AR model to an iPad out in the field, and then the iPad is Bluetooth to a high accuracy GPS, keeping the model accurately, so that as you walk around and he's doing this screen recording, it's showing you everything that as he moves that iPad around. That's what you're seeing here. What I like about this, one of the things I like about this, is that it's showing you your below ground features, not just utilities, but it's showing you structures, thrust blocks, or foundations, footings, things of that nature. A lot of people think utilities are the most important thing, which they are very important. I don't want to take away from them at all. But I've been on projects where we've excavated a thrust block on a water main and had the water main completely blow up in front of us. And that's no fun at all. Having something like this where you can have a good visualization in augmented reality gives you that feeling of this is what we're looking for, a little more anticipation. So as the engineer is walking around here doing this screen recording, you can see he's toggling off above ground, below ground. He's moving all directions, and he's kind of he's moving a little fast, but I think he's trying to see how much it wavers and so forth. And in this case, he's walking through a building wall. We put in shadowing effects to make this sunlight shadows, daytime. You can do all kinds of neat things with this. A little overkill, I guess, in my opinion, on some of that. But the bottom line is, it's the ability to see these features as you move around in an accurate way. The inspector on this project really liked this because as they worked on the job, utilities markings were getting, of course, wiped out constantly. Trucks and equipment were going over the markings, and they piled materials and so forth on top of markings, and they get wiped out. But he could align himself up and look at things and help to, I guess, make the job move faster. Kept things, I guess, a little. He said, he felt it kept things much safer. So that was a pilot project we did actually a couple of years ago. Nick, I think I'll let you take it from here.
Thank you, Troy. Okay, so yeah, that looked really fancy and nice and looked easy, right? But I guess the next question might be, so what do I actually need to do something like that? Like, going into it, what do I need? So, so some of the prerequisites for this are obviously geolocated 3D data, and that could be in a variety of forms. Could be like that compressor station CAD drawing we saw there. Could be a tab, a table of XYZ coordinates. Could be shapefiles, any kind of GIS data or CAD data, as long as it's geolocated somehow. So that's obviously the hardest part, right? That's the part that's a big part of what we're talking about in this group over and over again, is how is that data getting places and where is it coming from, that type of thing. So that's a big part of it, obviously. As far as hardware goes, you need a device that's AR capable, and most modern Android and iOS devices support it to some degree. Some are getting better than others just because of the advances in hardware. iOS devices are primarily what we work in. They're just a lot easier to develop for a variety of reasons. Androids are just more variable because there's a lot more brands out there and whatnot, and different OSs and things like that. And there's also the smart glasses, like I'm sure you've seen, like the Google Glass type setup, and there's other brands. Headsets like the Microsoft HoloLens are also out there. It's not really, those really aren't anything that we've done much with. We've experimented with it, and it just didn't suit what we were trying to accomplish. And we really think, using
commonly owned devices.
tablets and phones that people might already have or are readily available is probably a better approach, depending on your needs, I guess. Yeah, there's just some pictures I forgot. And then thirdly, some sort of GNSS/GPS receiver, if accuracy is concerned, which I assume it is for this group, because that's a lot of what we discuss is, the accuracy of the data. Obviously, your data accuracy is going to be variable, so it's not, just because your GPS is good doesn't mean you're gonna succeed at everything you're doing. But I don't know if you can see this, but we have the arrow goal, just like I have in the picture there. And we have a tablet attached to this little 3D printed bracket that we use for walking around using the AR app, and that works pretty handy. There's other, it's nice to have that all in one package where you can point. We tried it mounted on like a pole before, and that was a little more challenging because where the GPS receiver isn't where your camera is, and it just kind of is a little more disorienting, I think. It's nice to just have it where you're pointing is where it thinks you are. So that's why we went that route. Next slide. So my comment on the last slide about 3D data, and I guess this slide is just saying that if you don't have 3D data, don't worry too much, worry some. I mean, but there are ways, there's a lot better ways nowadays to make 3D data out of 2D information or 3D information that's in a non-spatial format. Like so this image that I have on the lower right here, which actually was a little video that I don't know why I can't get it to play anymore on presenter mode. Anyway, doesn't matter. So that on the lower right there, that's ArcGIS Pro in the scene view, and it's a pipeline with utility crossings there, and that was something I generated in a matter of 15 minutes from some tabular as-built data. So I had the X, Y, Z coordinates, of course, had the utility type, had the diameter of the utility, and in ArcGIS Pro, in pretty short amount of time, I was able to generate a model that could then be consumed in our AR app, anyways, pretty readily. And my comment there, 3D GIS software is finally getting good, is just because it wasn't that long ago where it would have been really painful in a GIS program to do that. You probably want to use an AutoCAD program, and you still can, but I'm just saying, well, a lot of us on the call are GIS oriented, so that's where I'm going with that. Yeah, an example of workflow for using AR. Obviously, the first thing you do is gather your data, whether it's as-built information, if it's something from a Lidar scan, field locates, drawings, excuse me, etc. And then at least the workflow that we typically use is we would convert that to either a CAD drawing or some sort of GIS format, like I did in the previous slide. So you're publishing the digital data from, in a GIS format or CAD format from point clouds or drawings or tabular information. And then our workflow, we convert to 3D format, and we use Collada or FBX typically as because they're pretty well. They're easy to convert to other formats, I guess is what I should say. That's why we usually stick to those two, but a lot of times we can ingest others and convert to that, or web scene. So a lot of you are familiar with, like the ArcGIS web scene viewer and web scene. So our app, we don't actually have that functionality in our app yet, but that's something we're wanting to look into adding. And then after that, it's just a matter of loading it into the device from a cloud environment, or if it's like a web service, that would be it. So it's I know there's a lot packed into my little workflow, but just to give you an overview of what types of things you're up against. I mean, it's not really as much work. The last three things are not that much work. The first thing's obviously the biggest challenge, which we all know. So some additional considerations about AR, and some things that people should just be aware of, is that obviously, because it's using your camera sensor as one of the primary components, lighting and weather conditions are very important. So if, middle of the night, it's not going to work unless you have a very interesting camera. And if you have a lot of rain or fog or whatever that's interrupting the camera feed or getting it on the lens, that's obviously going to cause issues. So you need a clear picture to really, I guess, use it to its full potential. Another issue living up where we do is snow, and you can think of a lot of reasons why, but main reasons with AR is it can sometimes have issues detecting the ground plane, so where it thinks the ground is, for a couple of reasons. Snow is highly reflective, so it can throw off camera sensors and other sensors, light sensors. So that can throw off where it thinks you are relative to the ground. It also, like the picture shows with the hydrant marker there, it adds depth. So if it does detect the snow as the ground, it's not going to be where the actual ground is. It's going to be above that where things are situated. So that introduces another issue. And yeah, anyway, and another really important thing to know is that as it sits right now in augmented reality, the world is a flat plane, because like I said, it the sensors determine the ground plane, or the horizontal plane, as the ground. So if you have a lot of topography or a hill, like that little sketch diagram shows on there, where it thinks the ground plane is where it detects it. And if there's an object way up high on a hill and the ground plane is here, it's going to put the object here. If the object is, if the object is, I guess, located on the ground in your augmented reality data model. Hopefully that makes sense. So hills are a problem. So like in Duluth here, finding a good location, some demos can be tricky sometimes. Going down to Canal Park works good, or up on top of the hill, but on the side of the hill might run into problems. Hopefully I've seen some, and we've heard about being able to incorporate like geoids and different 3D data models into AR, and that could help alleviate some of that. And the technology is ever changing, so I think we'll get there. And then the last thing that's really something to consider is how you perceive, I guess, things floating in space. So if we're trying to represent something that's buried underground, as that little snip on the lower right, I think that's supposed to be a gas pipeline. It's supposed to represent something underground, but it looks like it's floating in the middle of that car in front of it. So a big part of, I guess, getting the most out of it is, well, the AR people need to do a better job of maybe tricking people into seeing things and normally how they perceive them. Or else you need to do probably a little bit of tricking yourself to realize, oh, it's actually looks like it's floating because it's actually underground, but since it's overlaid on the camera, it looks like it's floating. So it's just some things to consider. So, I mean, and because these are actually probably almost as important as anything else, because if you're expecting it to work a certain way and then you run into these issues, that you're just gonna think it's not working, and it's not, and it's probably not gonna work out for you. So there are some shortcomings to it. And I think I'll just turn it back over to Troy for this next slide to talk a little bit about how we see this can be used.
Gentlemen, I'd point out you're running.
Yeah, some of the potential benefits of AR for underground utilities.
Troy.
Combined with GIS maps and 3D scenes, AR can provide an additional safeguard during locates, excavation, and other ground disturbance activities. Increased efficiency during locates. Utility markings get destroyed at site disturbances, as we know. Non-utility infrastructure can be included in the data, like I mentioned before, thrust blocks or footings. Better representation of assets will result in less injuries and less utility strikes. Overlaying construction plans can aid in design, planning, and installation of new infrastructure. Go ahead. A case study from Whiting Petroleum. One call department incorporated GIS and AR into their locating processes. Field crews were able to immediately see their data in the field around them as if they were stepping into their map. Whiting staff were able to not only streamline their assets management process, but improve the accuracy of their data. It enabled the company to save an average of 30 minutes of locating each asset. That's a pretty impressive amount of time.
All right, this is me again. So I hope that, is keeping a little light on you guys. I hope, and obviously we'll have hopefully some time for questions, but just wanted to discuss what we think, some of the things that we're excited about anyway. Obviously it's an ever evolving technology. It's evolving really rapidly, and you always feel behind, unfortunately. That's how we always feel. So I think there's a lot of exciting things coming. One of the things that that I think is going to be more and more commonplace is ways for AR to directly aid equipment operators. I mean, the technology's been around for a while, but I think it's going to become more readily available and probably less expensive and probably have more functionality. This is what I'm getting at there. Another thing I was talking about the formats we ingest, we convert to some 3D formats and whatnot, but going forward, the goal is to make it so you could, import a KML from Google Earth directly into the app and see the data. That's kind of the place we want to go eventually with it. Just an example I have there is that our Esri is actually included a AR component into their runtime toolkit, so that helps developers like us integrate with Esri workflows. So that's promising. It's been there for a while, but it's and it's being done. But yeah, it's just good progress there. One thing that I'm excited about is, I don't know if people knew about this or not, but there's actually Lidar scanners in certain newer versions of the iPhones and iPads. And combined with their iOS AR Kit 4 depth API, they're promising. I haven't really experienced many apps with it yet, but I'm sure we will. More realistic experience, just how it handles visualization of data models and whatnot as you move around, and also more enhanced features like better, more precise measurements in AR apps. Excuse me. So I mean, it's just a sampling. There's obviously a lot of work going on in this realm that I can't touch on in this amount of time, but yeah, I think it's pretty exciting stuff. So, and I think we're pretty much to the end there. I don't even know how much time we have left, or if we're way under, way over, but we went over. Sorry. But yeah, I don't know if we have time for questions or not. I guess we can leave that to the group here.
Barb, what would you like to do?
I think we need to move on, unless
Okay.
somebody has a burning question. That's short.
I've got just one, and it's very quick. What are you seeing in the way of accuracy with iOS and Android devices without supplemental GPS?
Oh, not much better than, like, I don't remember a number on top of my head, but not very good.
Okay. All right. Thank you.
Yeah.
You may have said it, but did you quote a price for that Arrow RTK?
10,000.
It was like 10,000 for that one. That's their highest end one.
Okay, thanks.
There are cheaper units out there.
Yeah, I looked them up a little bit. It looks like get in around just under 5 if you need to.
Yeah. So yeah, it's a little pricey for that particular model. But yeah, the prices are going down though.
Okay. Okay. Thank you, gentlemen. Really appreciate the presentation. It will also be online, and of course, Troy and Nick's information is posted there. You can reach out, and maybe during our open discussion session, we can circle back and try to clean up if there's any further discussion on it.